All right, so thank you for joining us for the Are You Ready to Nanotech webinar this afternoon. With us, we have Robert Ehrman, who's the Managing Director at the Penn State Center for Nanotechnology Education and Utilization. Within that center is the Nanotechnology Applications and Career Knowledge Support Center, which is funded through the National Science Foundation as an Advanced Technological Education National Center. Through the NAC network, offers 18 credit nanofabrication manufacturing technology capstone semester, which has provided nanotechnology workforce education to over 925 students throughout a statewide education industry partnership. Bob has worked for 23 years in the industry before joining Penn State. Bob worked for Corning, where he held multiple positions in engineering product development, as well as management positions in engineering, production, and project management. Bob earned a Bachelor's of Science in Ceramic Engineering from Rutgers, as well as an MBA from West Virginia University. Thank you, Bob, for joining us today. Participants, the objectives of today's webinar are quite simple. Nanotechnology is an emerging new field, just really breaking into sectors of education that are not directly tied to it. I've participated in a couple of the fantastic professional development opportunities that the NAC network supports and provides through the Center for Nanotechnology Education Utilization. And Bob is here today to give you a very brief overview of exactly what nanotechnology is, and also make you aware of two fantastic opportunities for you to participate in professional development coming up. At the end, I will address ways that our center, the Center for Professional Personnel Development and Ag Education, can support your participation in Bob's workshops, but we'll get to that at the end of the webinar. So Bob, it is all yours.
Okay, thank you, Jonathan. I'm going to share my screen. Hopefully, if I want to make sure that you can see that. Can you see? Let's see. What do you see right now? You see my PowerPoint?
Yep, we see the first slide of Are You Ready for Nanotech to Matter into Your Own Hands?
Yes. Okay. Great. Yeah. So the title of this PowerPoint or this presentation is, I like John's Are You Ready for Nanotech, but I've also have a kind of subtitle of Take Matter into Your Own Hands, the Nanotechnology Revolution. And when I say matter, I mean, the careers for people as well as matter. Basically, you're actually working at the nanoscale. And John, thank you very much for the introduction. That is me. You mentioned we have the CNEU, or Center for Nanotechnology, is the umbrella organization. We have multiple projects under that, and one of them is our capstone semester, which is actually available for high school students who are interested in learning more about nanotechnology at the next level, at the community technical college level. It's not really for high school students, but we hope that teachers will integrate nanotechnology into their curriculum at the high school level to make our students nanoliterate. Because hopefully, as you'll see at the end of this presentation, it's here, nanotechnology is here, and it's going to be growing for the future. It is embedded in multiple technologies, and I know this webinar is going out primarily to agricultural teachers across the state, science and ag teachers in agricultural areas, through the extension, I don't remember the name exactly, but through John's office. And I think that we want to make sure that our students are nanoliterate so that they can actually partake in this nanotechnology revolution in the future. So what I'm going to try to do today is I really am going to feed you with a fire hose for a bit, basically because I don't want to keep you here till 9 o'clock tonight. I want to be respectful of your time. I want to get it over in the time period that over in the time period that John prescribed, and I don't want to bore you to tears. So I'm going to tell you what nanotechnology is, something about size and properties, why you should care, or at least I think you should care, some impacts of nanotechnology today and applications, jobs, future predictions for where nano is, and how you can learn more if you're intrigued by what you heard today, talk about what an NPDP is, what some next steps you might be able to take. John mentioned a couple opportunities. One is a workshop that I'll give you a preview of, this NPDP, Nanotechnology Professional Development Partnership workshop, live stream workshop that's starting in October 9th. And then also some classroom resources. We may not delve too much into it, but I'll make this PowerPoint available. I want to end on time. The other thing we have is an opportunity that we're doing on a nationwide basis that we are actually leading here at CNEU through our NAC network support center, and that is actually a remotely accessible integration of nanotechnology day that is going to be on October 9th, and it will be available for you to bring high-tech equipment into your classroom at any time during that day from either our center here at Penn State or one of it. Right now, I think we have 11 centers signed up that you could actually go to, depending upon what time of day is. We're doing it across the nation, so we're leading that charge. That's for National Nanotechnology Day, and we'll explain why it's on October 9th in a minute or two, okay? So what is nanotechnology? I don't know if there's knowledge in the room about nanotechnology, but I'll just kind of move on to, so at this point, sometimes I'll ask what nanotechnology is, but I don't know what people know about nanotechnology, but it's a broad term referring to the manipulation of matter at the near atomic level, if you will. It encompasses many scientific disciplines, and it impacts our daily life and our future greatly. And you can see this scale here, and you can see, where we are as a person. A 6 foot tall is 1.62 meters tall, and you can see down here we're talking about atoms and picometers down in the 10 to the minus 15th, and atoms down in the 10 to the negative 9th, and so on. So you can see some of the things that are on this scale, and we'll go into this more in a minute or two. So what is a nanometer? I'd say it's bigger than an ear of corn. No, it's not bigger than an ear of corn. So what is a nanometer here? Let's see. It's a billionth of a meter, okay? 10 to the negative 9th. And thus, that is why we're having National Nanotechnology Day is October 9th, 10 to the 9. Okay. Anyway, I didn't make that up. That's actually through the National Nanotechnology Initiative. They do this. We're one activity that's happening on October 9th. So how many nanometers long is an ear of corn? And I did this especially for agriculture folks here. I tailored this one. So I don't know if you want to hazard a guess here. We have a chat window here, but you can also speak up if you like to. Doug, you want to take a guess as to where it is? I'll pick on you, Doug. How big is an ear of corn?
I'll guess D.
Doug, that is an outstanding guess. It is 203.2 million. It's about 8 inches. Is 203.2 nanometer, 203.2 million nanometers. But these are not just random numbers out there for you, because if you ever go on Jeopardy, you can actually learn. You'll have these answers there. In 1,000 ear, the number of calories in 10,000 ears of corn with butter, okay, with a pat of butter on it, is 1.4 million. Just so you know, okay. The number of people who live in Pennsylvania is about 12.8 million as of 2017. Looked this up last night. And the number of seconds in a year is 31.5 million. These are not just random numbers. These were very important numbers that you can use in your future. So in all seriousness, the nanotechnology is the creation of functional materials and devices and systems to control of matter at the scale of 1 to 100 nanometers and the exploitation of novel properties at that same scale. This definition was put together by the National Nanotechnology, by a group of scientists, engineers, and government folks back in the year 2000 or so. They actually created this definition. My former boss, the person who started this center, Steve Fonash, was a part of this of creating this definition. And really the term national nanotechnology kind of took off right around 2000 or so. It was actually coined in the 70s, but in 2000, the kind of this nano revolution is when it started here. And you'll see why in a couple minutes here. I showed you that scale earlier. You can see some naturally occurring elements here. and you can also see some biological elements here. This is the scale of one moving right to left. You're going bigger, if you will, and larger. So you're talking about the transistors. You've heard of transistor radios. You may not be familiar with what they are, but I'm going to explain them in a minute. It's the distance electron travels in electronic components. Back in the 1980s, when was in the micron range. If you look today, we're down in the nanometer range, like the 7 to 9 nanometers is the distance. So that's a significant change, and that's enabled this electronics revolution. Okay, this digital revolution that we have today. Think of the things that you had when you were a kid, and think how much they've improved today. You know, the things that have improved are because of this kind of nanotech revolution, if you will. You can see, though, that there's a lot of biological things that are out there in the nano range, or the micron or nano range. Bacteria is in the microscale. That's huge. Viruses are, though, in the nanoscale. And the definition is 1 to 100 nanometers. That's kind of loosely the size of the nanoscale. Glucose is down in that range. DNA, the building block of life, is 2.5 nanometers in diameter, if you will. You can see some other elements that are water molecules are a little bit smaller, and atoms, the atoms are in the angstrom range, 10 to the negative 10th, if you will. So that's where the atoms are, the diameter of atoms. So I'm going to show this video for a second to kind of give you an idea, just to get an idea of how big a nanometer is. You hearing this? Okay. Good.
In fact, all the world's people fit inside a car 10,000 times smaller than this little car.
So, if you just to reinforce that, if we all were, you and I and everybody in this room were a nanometer, and everybody else on the face of the earth were a nanometer in height, we would fit inside, all of us would fit inside a car 10,000 times smaller than that car. So that it helps me to get my head around how small a nanometer is and how small we can make stuff. You know, it's incredible that we can work at that scale, that size and scale. And if you remember when I was talking about that number line there, the scale line, you saw that, you know, we talked about transistors and things like that. This is a Radio Shack ad from 1991. Radio Shack, I don't believe I know they don't have any stores left. I don't even know if they have an online presence. I'm not sure if they're still there, but if you know, they were there for many, many years. One of the things they have there is one of these right here. I usually pass this around. You can see the size and weight of that. It's a little bit different than this guy that I have, okay? This other one that I have, and probably a little bit more functional. Probably has a little bit more functionality. Doug, what could this do? What could this do, this phone back in 1991?
Probably make phone calls, and that's about it.
That's about it. And its battery life was about 2 hours, basically. Maybe it wasn't very good. I mean, that's all it had. And you can see all the things on this page. You know, there's $3,100 worth of things on this page. So what's common about those things on this page that were there? Well, I'll give you the tip. All of them are, all the functionality that's on this page is now in these phones, basically. In your phone that's in your pocket. But in 1991, it was $3,100 to buy all that stuff. And it would not have been very practical for you to bring that stuff around with you. You have to have really long extension cords in some places, or very long, very big batteries to get these things going. So you can see where we've come from 1991 to today. So how did we get there? Well, nanotechnology, okay? That's the answer. That's this presentation here. So the transistors, if you notice, what happens is the gate, this is a source and a drain, basically, and this is a gate. So what happens is you would turn on the current and or allow electrons to flow from point A to point B, if you will, okay? And that's through digital logic, zeros and ones of digital logic. And so a 0 would say send, a 1 would say this, or the 0, you know, basically the 00111, 00111, you know, the digitized language would basically be able to send the signals. Well, you can see back in 1991 there, if you remember, there were microns apart, tens of microns apart. Now, as they shrink, basically the electrons don't have as far to go. So we're in the nanometer range. And obviously this is not to scale, because you saw how small that nanometer was. If you're 7 to 9 nanometers, those electrons are flowing, and you can think what it would take to make instruments like this, you know, and make your cell phones and so on like that. The accuracy and precision to be able to do that is incredible, and that's how we've that's how far we've come in the last 20 years. So this is just a kind of depiction. This is the cell phone I just showed you here. This is my 2004 cell phone. When I started working in this, after I came out of industry in 2004, that was my Verizon cell phone, my 2-year cell phone, free cell phone with the flip that had not much more functionality than what you had in 2004. A little bit better battery life, but also, you know, all I could do was text and call. And now you can see the functionality of my my cell phone today. This is my 2016, actually the one I have currently in my right here that I just showed you. So you can see the progression and see what the functionality has. So on this, on one fingernail size, if you will, back in the 60s and 80s, basically there would be 10 to the gate length was 10 to 30 microns. Then it became millions on the same size piece of real estate. These transistors and connectors, if you will, in the 1990s, there were millions of them on there, to greater than 10 billion. I said billion in 2019 on the same piece of real estate. So that's how far we have come in making this, making electronic devices. So what fits in a cell phone now? You saw it on the earlier slide. Just about anything you can think of, you can put on, and think more and more things are coming. And I'm concentrating on cell phone, but you can translate that to other electronic devices too that are out there. Okay. So how did we get there? We had to make the tools to be able to do that. Okay. To, you know, had to have the manufacturing tool set, if you will, you know, the machine shop at the nanoscale, if you will, to make those things, to fabricate. But you also had to have characterization devices. You had to be able to see what you were making, because without being able to see what you were making, how could you make it? How could you know you made it, right? So they would use tools like this electron microscope. Now they've been around since the 40s, basically, the electron microscopy. But now you can actually bring them into your classroom. That's one of the things we'll probably bring in on the 9th of October. You can actually have your students characterize remotely. But having these things basically let you make the things at the nanoscale, but also enabled us to look at other things at the nanoscale, and enabled us to make the electronic devices, but then also to move into the biological world, and things that were just theories before and were postulated were actually proven wrong, if you will, by looking at it through these devices. This is one of them, electron microscope. Another one would be like a scanning probe microscope, where you might have heard of an atomic force microscope. The way this works is that in the middle of this picture here, you'll see this needle here. It looks like a phonograph, if you will, and it actually rasters across the surface back and forth. And there's a laser that comes down, basically, and then comes into a detector and is displaced. And there's a piezoelectric device that actually said, has it, translates that image basically into a, or that signal into an image. And so you can then actually know what the surface of roughness of that is, what is on that surface. As a matter of fact, in 1986, IBM spelled out their logo using this atomic force microscope. And actually they moved, these are atoms, using atoms. They're xenon atoms. They moved around. This is moving, you're actually seeing atoms basically through this, or imaging atoms, if you will. Before, that was never done before. So this is kind of brand new turf. So that's kind of where one of the tools, and there's other tool sets. These are some of the workhorses of the micro nano world. So we talked about the first part of that definition. That was the size, the 1 to 100 nanometers. And then now I'm going to talk a bit about the novel properties part of this definition. Okay. I'll talk about the exploitation of it later on, the first part of the definition later on. So unique and novel properties. There's a bunch of them, but I'm going to concentrate on a few of them. And again, I'm doing this very quickly, but very large surface to volume ratios. That makes sense. If you're a scientist, you understand that. Geometry affects color, physical and chemical properties change, and there's very small structures, okay? So let's start on the very large surface to volume ratio. Obviously, there's a cube of the same volume. You have 27 cubes on the right there. Which is going to have the more surface area? It's going to be the one on the right? Obviously, because if you broke those apart, you're going to have 3 times in this particular case the volume for the surface area for the same volume. Okay, so when you're breaking things down into the nanometer size range, this is on the microns. Now think about how small, how much surface area you would have. So you have a lot more place for reactions to take place. So you've got high chemical reactivity at the nanoscale. Just makes logical sense. That's nothing new. You kind of knew that, I think, going into this presentation. But it's very important when you go into the nanoscale, because other things do happen at that nanoscale range. So for instance, the ratio is very big. You can see this. I just mentioned this, the high surface to volume here. You can see how small we get the surface to volume ratio gets here. But one of the things, like for instance, like gold, the melting point of materials, and let's pick gold for example, will change at the nanoscale. It will be constant up till you get to that near 100 nanometer range. If you can see, it's pretty constant moving across here, right? Now when you get down into the nanometer range, it rapidly changes because of that surface area to volume area and some other phenomena. So that's pretty interesting that changes at that size and scale, just in that sweet spot of 1 to 100 nanometers. What's very interesting about that also is that not only the melting point changes, but the optical properties change, the electrical resistivity changes, all these other properties change. So it's kind of interesting if you think about that. Geometry affects color. I'll go to the second one and talk about physical properties and chemical properties change at the nanoscale. So Doug, I'm going to put you on the spot. It's a tough question, okay? What color is gold?
I want to say gold, but it seems too obvious for this.
Okay, so you're going to say?
I'll go with gold.
Okay, cool. Well, that is the right answer. At the macro scale, okay? At the nanoscale, it's all of the above. If you remember, the title here was Geometry Affects Color, okay? So you can see in bulk gold is gold. If you cut that gold bar in half and you cut those gold bars in half and again and again and again and again and again and again, you still be gold. Until you got into that 1 to 100 nanometer range, then what you're going to have is colors of the rainbow, if you will. So you can see here that these solutions on the right-hand side are different size colloidal solutions of gold nanoparticles. They're all the same solutions except for the size of the gold nanoparticles. They were capped at a specific sizes. I don't know what the exact sizes are, 75, 60, 45, 30, 15, whatever they are, and they give you these exhibit these different colors. Kind of cool. Kind of cool if you think about it. And again, all the properties change at those discrete places. Okay, that makes sense? So if you look at, materials properties change, your activity, melting point, optical absorption, and so on, they all change at that size, scale and size. So this is an example of that. This is this is something that happened in the Middle Ages. This is called the Lycurgus cup. It's in the British Museum. And this cup, if you in reflectance, it's green, and in transmission, it is red. Okay, if you look at it in transmission. And this is a property that's had since the 4th century, if you will. But they didn't know why, exactly why. And the reason was because it had different size gold, has different size gold and silver nanoparticles in it. So the way the light reacts with this material actually gives it this property. You can see this in stained glass in, like, say, the cathedral at Notre Dame. The artisans used gold and silver nanoparticles. Don't think they knew they were using nanotechnology at that time. They knew that the specific formula and that they added to the glass melt gave them this color, But really, what they were doing was grinding, or whatever they were doing to process it. They were making specific colors in their stained glass. Okay, but now we have the tools that have been evolved to be able to analyze them and determine that, oh my God, they're gold and silver nanoparticles, and there are 40 and 300 nanometer and 240 nanometer gold and silver particles. So here's the unique properties at the nanoscale. This is just another depiction just to reinforce this. This is kind of a cool thing. These are different solutions, again, of different sizes. You can see the different colors that are exhibited there. There are also different chemistries. And they're also different shapes. There's spheres and platelets in there. So what can you make with this stuff? Well, the answer is just about anything. If you think about all the elements on the periodic table and all the possibilities out there, the permutations and commutations are endless. Okay, so I'll give you another thing. Physical and chemical properties change at the nanoscale. Things that have been discovered in the recent past, in the last 20 years. We all know the 2 different allotropes of carbon, graphite and diamond, 2 very different materials, right? But really both carbon based. Graphite's very soft and basically is just sheets of carbon, and diamond is tetrahedral arrangements of atoms, and they make it very, very strong. It's one of the hardest materials known to man, if you will. Now, if you look at the nanoscale, when we got those instruments to be able to analyze at the nanoscale, we discovered in things like fire, there were things out there that we did not know were there. Things called buckyballs, okay? And carbon nanotubes, okay? And buckyballs look like a soccer ball, if you will. There's C60 and C80, and I think there's C120. I think there's different allotropes there of these buckyballs that have been discovered that are there. They're just there, and now they're looking for applications, and there are some possibilities of where these things are going to be used. But we didn't even know they were there until we have these tools, and there's other things to be discovered at that scale. Now, carbon nanotubes are incredibly strong for their size. Basically, they are 10 to 1,000 times stronger than steel. So carbon nanotubes are used as, if you will, nanoscale rebar. So they're put into things like I'll give you one here. This is a baseball bat, okay? Into this area of the baseball bat basically is they started putting them in there to make it stronger and lighter weight. They put them into golf clubs and things like that. That's where the kind of the low-hanging fruit for this stuff was, to make them bicycle frames and so on like that. However, now those are kind of like, okay, sporting applications are kind of cool. But what about airplanes? What about boats? What about, rocket ships? What about, cars? Energy efficiency? Well, that's where they're playing now, basically. Anything that you want to make stronger and lighter weight, they're using these nanotubes, and they're not very expensive. Basically, they know how to make them. They can make them by the truckloads, if you will, and a little bit go a long way. So that's something that's kind of cool. I don't know if you guys you'd ever heard of that before, but that's a new application, if you will. And then, not to belabor this, I want to talk about what, you know, we talked about small structures. We got smaller and smaller. We talked about it earlier. By getting smaller and smaller, that enabled the electronics revolution that we're in right now. Okay, so to me, what you have is we have a whole new treasure chest of materials to discover and explore and use, and that's basically the periodic table. And instead of having a two-dimensional periodic table today, we have a multi-dimensional periodic table, if you will. You know, you saw those at gold, you had the different levels at the different sizes. Well, think about all the other elements that are out there and all the discoveries to be made. These are just the low-hanging fruit that are out there. And we don't know what the next, what discoveries are going to be made. People are doing research on elements and different materials and combinations of materials all the time. So lots of stuff to be discovered at that nanoscale. So these are the things that we talked about, and that's what makes the nanoscale special. Okay, so that's kind of ending that segment. I wanted to spend a couple moments on why nanotechnology, kind of like why I think it's cool. You've seen some of the reasons before, but are there applications for nanotechnology? We just talked about a couple mundane ones, and from a standpoint of bats and things like that, but think about the carbon nanotubes, all those things that are out there. But also we had things like cell phones and things that are out, the electronics that are out there. So this is an estimate that was made a while ago. I don't put too much stock in the exact numbers, but I do believe that the trend is going to be, straight up, if you will, that products incorporating nanotechnology will increase by 100 times over 2 decades, and that prediction was made in 2010 or something, and it's supposed to go up to over 2 decades to 2020, from 30 billion to 3 trillion in 2020. And I got to tell you, we're ahead of that curve. This was predicted in 2010. There's more than that. I think the last one I saw was 4.22 trillion in 2018. So things are moving more rapidly than they thought 7 or 8 years ago, if you will. So these are just some products or examples of products. We could spend a lot of time on each one of them, but these are different areas where nanotechnology is impacting. And I'm going to go into a couple of them. Where is nanotechnology used today? Semiconductors, we talked about that earlier. Electronics industry, pharmaceuticals, we'll talk about that in a little bit here in a couple moments. Colloidal chemistry, polymer science, material science, medical and biotechnology. And one thing that's not on here is the agricultural industry. It's all over there too. The only reason it's not on there is because, and others aren't on there, is because the slide isn't big enough to put everything in there. You can put just about every industry is impacted by nanotechnology. The nanotechnology industry initiative is actually a initiative by the federal government. It's actually the NNCO, the National Nanotechnology Coordination Offices in DC. They have a website called nano.gov, which I highly recommend if you want to get some more primer on nanotechnology. And this is about, I think that 2015, their vision was a future in which the ability to understand and control matter at the nanoscale leads to a revolution in technology, an industry that benefits society. Okay. Thus the title of this presentation, a nanotechnology revolution, okay? And what they wanted was R&D for the country, okay? This is US based, but this is not just happening in the US. We're leading the world, but it's not just it's happening all around the world. R&D, but R&D in itself is great, but it doesn't fuel the economic engines totally. You have to have products to sell. So you need products, you need to turn that into products. You need a skilled workforce. Those are the people that you're teaching right now, okay? Or and they need the infrastructure. That nanofabrication facility that John was talking about earlier here at Penn State is one of the pieces of infrastructure. The tool sets that industry has, the infrastructure, they need that infrastructure out there to be able to make these things, these tool sets that fabricate and these tool sets that characterize. And they want this done responsibly. Okay, they want to make sure they don't have any bad actors out there in the in future things that we're going to be regret. So they want to go into this with eyes open and to analyzing where things are going and what's being utilized. So you can see on the outside ring of this, you can see all the government agencies that are associated with this. And they're not doing that to be a part of the cool kids. They believe that it's the right thing to do. They all have nanotechnology initiatives. Okay, cool. So this is, where are we? I mentioned before, you can see that what they said in 2012, well, here's the bottom line here. They're this was in 2014, their new prediction was 4.4 trillion. And I believe I saw some numbers last year that they said they were on that track, basically. By 2020, this is another prediction that was made by Mihail Rocco. He's one of the founders at NNI that I talked about earlier. He works for the NSF, brilliant scientist. By 2020, 70% of all new advanced technology products will incorporate nanotechnology. 70%. That's a big deal, okay? And the question is, will your students have the training necessary to compete in that workforce? I do this as and basically when I go out and do recruitment to people, I say, will you have the training necessary to compete in that workforce? So it's important to bring that to students and let them know that, hey, getting some training in this area makes sense, as a foundational knowledge for your career. So a key challenge is for nanotechnology development is you got to have a skilled workforce, okay? And so we're actually a center, and we started this center, and part of our role is to, if you will, spread the nano gospel across the country. And we've helped to create workforce development programs in nanotechnology at many places across the country. So this is an example of I don't know why I put this in this thing. I don't know if it's misplaced or not. Maybe it is, maybe it isn't. Let's see. Oh, these are some nanotechnology examples. My apologies. This is some things I mentioned earlier, the Lycurgus cup. Nanotechnology is not new. This is remember those nanotubes and nanowires. If you've ever heard of Damascus steel, basically, that's Damascus swords. It was the weapon of choice in the Middle Ages. Basically, very sharp, very strong. When they looked at it, they were trying to replicate the process to making that steel. And when they were doing that, they analyzed the materials and figured out that through the processing and through the formula that they used, they created nanowires and nanotubes. Remember how strong they were. That was one of the key elements that were there. And if you look at some of the swords that the Vikings used, you'll see the same thing. That through the processing, they created these nanowires and nanotubes, and that made them very strong. Okay. So here's some very diverse applications of nanotechnology. I mentioned it was all over the place. You can see some of the areas in medicine and textiles and in biomimetics, which is copying of nature, in energy, clean water, sports, household products. I'll show you, I know we got to end in a couple minutes, but I'm going to show you a couple of videos real quick here.
This animation depicts keystone nanotechnology that treats cancer more effectively than current therapies. Keystone Nano is building on technology developed at Penn State and the Penn State Hershey Medical College. Keystone Nano assembles nanoparticles containing a therapeutic drug. With trillions of particles per ounce, an IV solution packs a big punch. The nanoparticles circulate in the bloodstream. Their structure and size, which is much smaller than a blood cell, allows them to travel in the body longer than free drugs. To support growth, tumors create blood vessels to supply nutrients. But typically the vessels created by tumors are poorly constructed and provide small gaps to access the tumor. Particles slip into cells and selectively kill tumor cells and shrink tumors. More information is available at keystonenano.com.
Okay, that's one company in central Pennsylvania that's fighting cancer using nanotechnology. That's actually in the material science department here at Penn State, working with Hershey Medical Center. And they just got a gazillion-dollar grant. They're going to trials basically for this stuff. Probably not a gazillion. I don't even know what a gazillion is. But so you can see that that's one area, probably the most important area, fighting diseases, detecting diseases, nanotechnology, all these other things are kind of cool. But when you're talking about human health, that probably is trumps it all. So here's another one that I think that is extremely important.
Okay, this is never wet, super hydrophobic fabric system. This particular model, we also make a paint that paints on surfaces. But with this product, you can spray it on any clothing, and it will make your clothing super hydrophobic. Water and heavy oils will just shoot off of it. Chocolates, ketchup, mustard, all of that sort of thing. Hydrophobic means that a surface is water resistant. Super hydrophobic means that the water will shoot off of a surface, won't even sit there. When you plunge this in the toilet and pull out, it remains dry. And with it staying dry, it doesn't have any bacteria. We made the outside of this very hydrophobic, and the center of it is untreated glass, which is hydrophilic. In other words, the center of the glass wants to attract water. The outside of the glass wants to repel water. So when we pour water in the center, it goes to the borders that we created with the hydrophobic surface and it stops the water.
Okay, so I will stop on that one. I could go through all of these. When you get this video, all of these are linked to videos. Okay, so if you wanted to show this or do this in your classroom, it's right there for you. You want to look at or whatever, it's there for you or whoever wants to use it. This one thing about this mural, if you will, or collage, is that all of these I picked out are all Pennsylvania applications. Okay, Pennsylvania people. And I would submit that you could throw a dart anywhere in probably some of the more more advanced tech areas in the country. Throw a dart and you can do the same thing and find companies around there that are working in particular areas, and they might have their specialties or whatever, but they're all kind of working in the nano world, using nanotechnology to improve their products or processes. They might be their tool sets, whatever it might be. They're improving them, making them harder, making them last longer, making them more economical, better quality, if you will. Matter of fact, that one that I just showed is right in Lancaster County. It's a company called Ross Nanotech. Used to be Ross. It is Ross Technologies, and they created a bunch of different super hydrophobic things at the behest of military to make super hydrophobic surfaces, and then they got into commercial applications, and they sold some of them to Rubbermaid plungers, and they sold some of them to Rust-Oleum. And you can go to the store right now. You can go to Walmart. Actually, you can go to Ollie's and buy this stuff, if you will, and you can get coatings for different stuff. You want to make your stuff super hydrophobic, you can do it. There's no excuse why you couldn't do it right now, and the stuff works, but it depends on, you have to get the different ones for the different types of materials. So I'm going to move along. I'm not going to show this one. This is a cool one, but I'm going to move on to, in the interest of time, there's things for clean water. There's filtration systems. This is a company in Mount Holly Springs, Pennsylvania, that makes filters, that filters out stuff down to the nanoscale, viruses at the nanoscale. I use this when these water bottle filters, when I went to visit my son who lived in Mexico, and then he lived in the Middle East. I used bottles that had this to make sure that neither my wife or I got sick while we were there. And then also now but some of these are being used in third world countries for large water systems to clean their water and so on. So it's impacting, nanotechnology is impacting, the environment as well. So let's see here. So I told you where nanotechnology is used all across the world. Okay. And okay, I want to, I want, if you want to know more, I want to, how do you get more nano knowledge? This is one of the places where you can get some more nano knowledge, if you will. I mentioned it earlier that we have workshops. These are 4 sessions for intro to nanotechnology, and it's way more in depth that I just went into. I just touched the surface of it, if you will. But there are 4 sessions on Friday afternoon, Friday starting at 11 Eastern to 3 p.m. Eastern. It's for high school teachers, community technical college teachers, university folks to come in and kind of learn about nanotechnology. And it's not just kind of what I went through, the applications and stuff, but more in depth about the processing and the tools, talks about clean rooms, and gives you kind of a general understanding. So when your students ask you about it, you have that knowledge. Basically, you'll have some knowledge about the nanoscale and something that moves into the future. You can get that at our website, which is nano4me.org. Nano4me.org is where you can go to be able to get that, and you can register if you want to do it. We're going to have an intro session in October, and then we'll have one on that's 2 weeks off, and 2 more weeks in November. And then we have one that's in February, every Friday in February, the same kind of schedule. And then we're going to go into the upper level workshops, and they're going to be available in March and April of next year. So that's one area. John, you have another one there. I just want you to, well, actually, before I go there, I want to tell you a little bit more about it here. A little about that. I'm going to switch over to you in a second. And then there's vetted sources of nanotechnology to bring into your classroom. I'm not going to have the chance to go through all of these. I'll briefly go through the slides. You can see that they're there, but I encourage you to take a look at these slides later on, if you will. But I want to show you a couple of things that we have, and it fits into that October 9th Nano Days event that we are having, that we are a part of. We actually started a network to bring these instruments into the classroom. Doug, I think you said that, you know, you like technology in your classroom and bringing technology in your classroom. Here's an opportunity for you to do that. And you can actually get online using Zoom, all right? And you would actually go in and you can actually do laboratories or access equipment from your classroom, okay? And not just access it, you can have your students control it, if you will. So it's desktop sharing. So you can actually go in there and actually share the desktop and actually interrogate samples at the nanoscale. Cool stuff, really cool. So you can get on that SEM, you can run a scanning electron microscope, you can compare it to what you could see perhaps in your laboratories there under a microscope, and see at the, you know, at the hundreds of micron level, and then see, oh, now what does it look like when you're down at the nanoscale? You know, a lotus leaf where the water, you know, the water flows off and is hydrophobic. Okay, you can see what it looks like under a microscope, and then you can see what it looks like on the nanoscale and say, aha, I get it. Butterfly wings, you know, cool stuff, but also cool stuff like circuit boards and things like that. You can look at that kind of stuff and get an idea of what they look like. So we can go to any classroom in the country, and what's cool about it, it's free. And we have, I think we have right now 20 or 21, I'm not sure, we got one coming on board, different institutions across the nation that are sharing and through this remote access network. You don't have to come to us. You can go to any one of them and say, hey, I'd like to look at your FTIR or your AFM. I'd like to do that. I'd like to try this. I'd like to bring this into my classroom. And you can actually interrogate samples. You can make your own samples and you can send them in, or you can do the stock samples that we would have within our thing. You can say, oh, somebody says, I'd like to, we did this experiment here. Let's try it. We have some canned experiments on our site too that you can actually look at and say, oh, this fits very nicely into this unit that I'm teaching. You know, you can say, oh, this is cool, and I can upgrade my classroom materials and utilize this material here. So this is the current RAIN network partners, and as I mentioned, they're all across the country. So the one thing I want to tell you too is you want to integrate nano. Oh, before I do that, can you, the 10.9, do you have that one slide? I'm going to stop the sharing, then I'm going to go back to that, and then I'll stop for 1 second here. You want to share for 1 second, no, yep. Jonathan, that one thing about it? Some of the details, so it's on the.
See that?
I can.
Okay.
So you can see we have this open house. It's the National Nanotechnology Day. It's October 9th from 9 to 6. And if you saw those sites across the country, 10 of those sites right now are a part of it. We may get more to there. You can go on for 15 minutes, 30 minutes, 16 minutes, whatever it is. And there might be other people on there. We ask you to register so we know who's coming. But then that way you can go in there and actually either observe and or you know, actually share with your students. It depends on who's kind of the primary there, and we're going to try and switch. We're going to have different breakout rooms. If we have a bunch of different people at one time, we'll break them out to different sites, if you will. So we're covering the whole day so people can get a feel for this technology and how they might bring it in. It's just a teaser, if you will. And if you even just want to go in on yourself, that's fine. Does that sound good? Okay, John, can you let me stop sharing, and I'll go here and go back and share mine. Hold on a second. I'm going to share, and then I'm going to wrap it up here in a minute or so. I do want to tell you about a couple things here, and I'm going to rapid fire go through this. If you want to go integrate nano, that's Rocky on the right hand side there. Don't reinvent the wheel. Okay, There's tons of materials out there. We've been in this business for 20 years. We've created a lot of materials, and there's lots of others. You saw some of those sites across the country. Some of them we helped start up. There's materials out there. Some people focused on K to 12. Some of them focused on community colleges. And there's other materials out there. We got lots of resources. And if you don't know, ask me. I'll let you know where it is. I don't know all the material, but I can tell you where it is. Oh, that's a really cool thing that's out there. We can't do justice today, but there's all kinds of different materials out there. If you look at this PowerPoint later on, you'll see some of them that are there. There's some really cool things that are out there. There's the big ideas of nanoscience. This is a really cool book. It's like $7.99, I think, on NSTA, and it actually is. It tells you about these different areas, but it also tells you some misconceptions about nanotechnology, and it's really well done, I think, from a standpoint. If you're going to teach it, you really should read this book, and it's an easy read for a scientist. There's nano.gov I mentioned. There's lots of different things, but one of the things, our portal is nanoforme.org, as I mentioned earlier, and I want to tell you about some things that are on there that do apply to ag that are here. We have introductory level modules about the history of nanotechnology, how small a nanometer is, basically some applications, what's unique at the nanoscale, and more depth than I talked about in this last 45 minutes here. But also, one of the things we have is at the upper level that we teach our undergraduate levels, but they really apply to teachers as well. There are applications of nanotechnology. Our 215 course has applications, videos, and trainings, if you will. And there are actually two in food, if you will, okay, or food and agriculture, if you will. So I would highly recommend taking a look at those. You just have to sign up at Nano for Me, and don't get scared away. It's just, it asks you to sign up, but the only obligation is if somebody says, I want to survey you, they're going to ask you to fill out a survey potentially later on, but it's totally free. It's funded by the NSF. But there are PowerPoints, PDFs, videos there. You can look, I mean, you can get lost in there for days on our website finding the materials, but I wanted to point you to these particularly, these nanoscale science and technology for food. This was done by an emerita professor, Dr. Lynn Brown, who retired a couple years ago here at Penn State in the food sciences area. And the second one is a nanotechnology impact on agriculture and food. And this was done by our founder Steve Fonash. And actually, he actually researched this and talked about some of the food packaging, how food is being used in agriculture in different arenas, and how the tie to nanotechnology there. I think it's really good. It's worth the time if you want to talk about it a little bit, if you want to learn a little bit more. This is the one that's in the Lynn Brown's. This is about, and this is the one that's in Dr. Fonash's. It was done in 2014. I looked up some papers. There's tons of papers on nanotechnology in agriculture, and how it's being utilized. So these are other things here. I'm going to really go through these. These are some videos. These are some kits that can be brought into the classroom. This is where a lot of the nano workforce stuff is. And my caution to you is don't reinvent the wheel. It's all out there for you. So that's all I got.
Okay, fantastic. Thank you, Bob. As you can see, the world of nanotechnology, nanoengineering, and nanoscience opens up an unlimited treasure trove of possibilities applicable to every aspect of the agricultural industry. And while agriculture may not be at the forefront of developing and utilizing or discovering these nano principles, our students, who, as Bob mentioned, are the future of the nano workforce that is in high demand. As Bob mentioned, numerous companies already in Pennsylvania that require a nano literate, nano educated workforce. They don't even begin their journey. They don't even begin their nano education until we, as the ag teacher, have that conversation and bring that to their attention, that this world even exists. I mean, we're talking about taking the periodic table and adding a third or a fourth dimension to it, and changing what we thought we knew about the natural world and matter. Very, very new and innovative, progressive stuff, but absolutely a chance for us as ag educators to direct our students into this new and emerging world and equip them, if nothing else, with some of the basic principles behind this, as well as direct them towards the various resources and educational opportunities waiting for them. So to anybody, to Doug and to anybody that hopefully is able to view this webinar after we wrap up here this afternoon, as part of the mission for the Center for Professional Personnel Development and Ag Education, we would like to encourage Doug, if your schedule permits, and anybody that sees this recording, anybody that's interested in participating and registering for the 4 Friday Introduction to Nanotechnology workshop sessions that Bob mentioned. We have funding that we can provide to sort of make it more palatable to your school and your district to support you in attending those workshops, as far as providing substitute coverage. I mean, ag teachers are out enough already throughout the school year. We understand asking for 4 more days for you to, hop on a computer and participate in those web sessions for 4 Fridays throughout the fall here may not be the first thing an administrator wants to hear, but we can provide funding to cover your substitute for those 4 sessions, if that's something that would entice your administration to support you in pursuing that workshop. So if you're interested, please reach out to me. And that goes for Doug as well as anybody that happens to see this before the September 28th registration deadline, which is next Friday. It's coming up quick. So if you're interested, and I cannot recommend that to you enough, see me and we can cover the costs of your substitute for those 4 sessions if that's something that interests you.
We thank you for that, your center for that. We really do, because it really is we really struggled with it's a partnership. We have people all across the country who are we're doing this delivery. And when we talk to the folks, it's really focused on, our sweet spot is a community technical college, and Fridays were the best we could do. They said, we tried to come up with days, and we had to come up with a day, and Friday afternoons seemed to work Friday, and we had to try to get the whole country in. So that's why we did it. And we know it's a sacrifice, but if we can get it's better than having to go. I know, not from a standpoint of, but maybe impact, but from a standpoint of impact to your schools, of having to go somewhere for several days. Basically, we're trying to make it a little more palatable. So
now I participated myself, and a tech ed teacher that I collaborated with quite a bit did participate in this specific workshop, I believe, when it was a face-to-face seat time event, and it was fantastic. Bob and all the guests that were brought in as part of that training is really what hooked me into pushing this into the ag ed world and incorporating it as much as possible, because look, nobody's asking you to become a devout believer and follower of nanotechnology, but you can't begin to have that conversation correctly and with doing it justice with your students unless you yourself are comfortable with some of the basic principles of what's involved with this. And I can also attest that in addition to this webinar, I'm working very diligently with the College of Ag faculty that are doing research in the nanotechnology spectrum. And it goes on from a gentleman over in Ag and Bioengineering that's working in utilizing nanocellulose in various applications. As we already mentioned, nanotechnology can extend itself into pesticide application, plant and pest monitoring, disease monitoring, water,
soil.
Yep. Get into the veterinary and biomedical aspect. The lists are just truly endless of possibilities as to how this marries itself with agriculture. But again, we can't even begin as ag educators to have those conversations with our students until we ourselves have a basic understanding of this world. So
Yeah, and our objective is really to just to get more nano literacy out there to folks, because you can see why, that things are changing in the last 20-ish years, and I know that schools have not really kind of shifted gears. They're teaching, you could teach science and technology utilizing nanotechnology, and then students would become more familiar with it as they go along. That's our hope. From K to 12, they're really starting to learn from K. And some countries are actually doing that. They're actually integrating nanotechnology at the K level, if you will. So, cool.
Okay, well, we ran a bit over time. Part of that was my fault. However, Doug, do you have any questions here before we end the recording that may be beneficial to anybody that views this recording after the fact? Okay.
Thank you for coming, and we thank anyone who watches this recording. And if you have questions or concerns, you can take a look at our website at nanoforme.org, and you can contact me through there or through John. You get a hold of me through there.
Absolutely.
Send me an email. Okay.
Okay. Events that I have planned. October 3rd, I have another phenomenal guest that will be joining us discussing the topic of appropriately and respectfully engaging transgender students in the modern classroom. Brian Pachkowski from the LGBTQA Student Resource Center here at Penn State, newly appointed to a Pennsylvania State Commission on LGBTQ affairs by Governor Wolf. Very excited for that opportunity. And then also coming up as part of the first series, or first session rather, in a series I'm developing called the Connect to Industry series, on October 10th, 3:30 to 4:30. We will have Ian Groy, an arborist with Bartlett Tree Experts, joining us to discuss and lead a discussion on the applied plant and soil science as it is used in the arboriculture industry on a day-to-day basis from a